Hi, today I'm going to explain why you need to understand the dB scale and how to calibrate your equipment for voltage units, for dBV, or for dBu. All these crazy units, what do they mean? What's the difference? Why should I even care? That's what we're going to talk about today. So I've got the simplest possible configuration first here. I just have a guitar which is hooked through a meter and then goes to a amp. The amp is there just so you can hear the sound. But what I want to show you with this is what kind of voltage level a typical guitar puts out. This is just a standard digital voltmeter and ohm meter. I've got it set to AC volts. It's on the 2-volt scale here, and it's going to display the volts in RMS, which means root mean squared. I'll explain that in a minute. The point here is I've got the volume maxed out on both my pickups, and I'm on the center position. My tone is somewhere in the middle here. If I strum these, I'm going to get somewhere around a peak of 0.1 volt. If I strum real hard, really dig in, I can get up to about 0.18 volts. But that's for context. That's your raw guitar signal. I apologize in advance, but today's lesson is going to be a little bit of math. So, first, I mentioned RMS. RMS means root mean squared. And all that is you take the square root of the average of the signal. And there's several ways to write this, but I'm going to write it sort of in a calculus way here of your signal. And then, so root, that's the square root, mean, 1 over the period, time integrating over the period, squared. We take our signal and square it. And this gives us the RMS value, X RMS. And it's a really complicated formula, but basically what it comes down to is if your signal is a sine wave, that means it has a single frequency, then your RMS value is equal to 1 over the square root of 2 times the peak value. Now if you have a more complicated signal, a guitar signal typically is not a pure sine wave. So a pure sine wave looks like this. A guitar signal is usually a sum of many sine waves, and it might be somewhat complicated like this. And so when you take the RMS of that, you're going to get a different value than you do with the sine wave. Just for your reference, I'm mentioning that. You could also have guitar signals that look more like a triangle, and they're a little wiggly like this. This is what you see when you play a guitar signal into an oscilloscope. So this formula doesn't work for actual guitar signals, but it does apply to a sine wave. And it turns out that all of the standards are based on a 1 kilohertz sine wave. So when you go to calibrate your equipment, you're going to be using a 1 kilohertz sine wave. And so that's where this number comes from. And it's handy that we can measure that easily with one of these voltmeters. These are abbreviated dB, the lowercase d and a capital B, and that's actually because Bell was the guy's last name, and deci means 1/10. So 1/10 of a bell. Who cares about that? Let's look at the formula. Alright, so to get your voltage in decibels, that is equal to 20 times the log base 10 of the voltage that you're measuring divided by some kind of a reference voltage. And now, the logarithm is really handy because it allows us to compress enormous range of volume levels into simpler numbers. So for example, log of, well, I'll put a 10 here. We can eliminate the 10 if we just assume it's base 10. Log of 1,000 is 3. You can basically count the zeros. Log of 10,000 is 4 zeros. Log of 10, 1 0. You get the idea. What about log of 0.001? Well, because that's got zeros Below the 1 point here, we actually start to go negative. So this is actually going to be -3, because if I move the decimal point 3 times, I get back to log of 1, which is 0. And if you have a log of some funny number, like log of 3, well, I don't bother memorizing that. That's why I have a calculator. So we take the number 3 and we hit log. Oh, this one does it backwards. We have to say log first, and then 3, and then equals. And in that case, log of 3 is 0.477. I probably wouldn't have been able to get that without a calculator. So what's the point of this? Well, this allowed us to compress number 10,000 and the number 0.001 in a range of -3 to -4. So we've been able to get those numbers squeezed down into a really small range. So that's what this decibel scale is all about. Sound occupies an incredibly wide dynamic range, and that's why we use the log scale to describe it. Okay, so we want to use a voltage reference. Let's talk about some of the references. First is the VU scale, which is probably the most common one, at least in the USA. That's the scale you're going to find on a mixer like this. This scale on the side, although it's not labeled, it is actually voltage units. It goes from 0 up to +10 and 0 down to -30, and those are actually voltage units. And so that scale is that 0 voltage units is equal to 1.228 volts RMS. It's a really strange number. Why did they pick that number? You know, I'm not sure. I'm not even going to try to guess. But what we want to do now is calculate what's another number on this scale. So let's say -20 voltage units. How many volts is that in RMS? Well, to get that number, we're going to go back to our equation here and start inverting this to figure out what we need to find. What we're asking for is what's this number on the top. And so we need to do some math here. We have to divide both sides by 20, so we're going to have voltage in decibels divided by 20. So that gets rid of this. And then we have to take 10 to the exponent on both sides. So 10 to that, and that leaves me with V divided by VR. Okay, so now my voltage that I want divided by the reference voltage, which is this number, is going to be 10 to this power here. Now I'm saying I want -20 voltage units, so that's going to be 10 to the -20 divided by 20. And that simplifies to 10 to the -1, which is equal to 0.1. In other words, my voltage that I'm trying to see here, if I rewrite the equation, the voltage that I want is 0.1 times the reference voltage. The reference voltage is this number, so the number that I'm after is 10 times less, 0.1228 volts RMS. And this, you're never going to get this accuracy from a meter. We may as well just round it to 123 volts RMS. And even that's pushing it. We don't need that much accuracy. But there's my answer right there. 0.123 volts RMS. -20 voltage units is that voltage. Now, remember our guitar signal? It was about that scale, about 123 voltage units. So basically, our guitar signal on a mixer board is going to show up at -20 voltage units. Well, that's not very helpful, is it? Because the scale on this thing goes up by numbers of 10 dB at a time down at the -20 scale. If we have our guitar signal down there, we're not going to know if it's 25 or 15 because there's just not enough resolution. We want to be up near 0 so we can see if it's +2, -2, +4, -4. That's resolution that we can adjust things based upon. So how do we do that? Okay, so the setup here looks complicated. It's not that complicated. I've just got my laptop going to an AC meter, going to a soundboard, going to an amplifier. So laptop, AC meter, soundboard, amplifier. Now I'm on a website that gives me the ability to play a sine wave, and I've got it set to a kilohertz, and I can vary the volume here, and I can also vary the volume through my laptop's controls. Between the two of those volume controls, I want to be able to get 1.28 volts RMS on this meter, with 1.228 volts RMS, which is the dB the voltage level for the VU standard. It's a good time to talk about some of the standards. So here's one. 0 voltage units equals 1.228 volts RMS. This is the most common one. You can also have dBV and dBu. And these are both different voltages. And I'm going to look them up in a second and we'll finish talking about this. But these two are a little bit obscure. One is 0.775 volts, and I can't recall what the other one is. Actually, I think dBV is just 1 volt. I'll write that in there for now until I get corrections. And I think this is the one that was 0.775 volts. Volts RMS. But you're not going to use these bottom two. This is the one that you really want. So let's turn this on and see if we can get this all set up right. So I'm going to press my space bar. I get my sine wave, and now I'm showing 1.31 volts here. So I got to drop my voltage a little bit. So I can use the slider on the screen here and try to get as close as I can to 1.228 volts. Wow, that's really close. 1.229. Can't get any better than that. Now my soundboard is actually showing +2 over here. And that is because I'm running through some gain on the soundboard, of course. And so I have to turn that gain down just a little bit. So I'm going to turn that down till the 0 just barely turns on. And now I'm pretty much calibrated 0 VU on here, my voltage there, and this guy. So now when I turn this on, I'm confident that I'm getting 0 voltage units out of my laptop. Alright, so now we can start putting in our voltage unit pedals and see how that works. Now I've added 2 more things to my signal chain. I basically wide off the signal here, and I'm going into the mini vump and then into the analog vump. So I've got the same signal going to the guitar amp and the 2 vumps. And so now we will show you how to calibrate those to our 0 VU signal level. Alright, so here we go. I'm going to turn on my signal. And both of these meters are showing way off scale, so I got to turn this cal knob down until I get this guy at 0 voltage units to get it to match to my soundboard. And same thing on the mini vump. I can turn down the signal level with the knob on the front. Except this one's only going down to 1.0 dB. I can't actually get it down to 0 because, well, the adjustment just doesn't go that far. But that's okay, and I'll explain why in a second. So I now have this analog meter calibrated to my soundboard. So let's turn the signal off, and we'll hook up the guitar and try to show what happens. So I can just unplug these and stick them into my guitar, and I'm going to strum my guitar. I'm getting about -24 on the mini vump briefly when I strum real hard. Maybe -19, and then the same thing on this guy. I can just barely crack the -20 on there. Well, that's kind of stinky, right? I mean, I can't see my signal. The reason why is the guitar signal, as we checked at the very beginning, is just way too small for the VU scale. The VU scale is meant for like a 1 volt kind of range, and our guitar signal is at -20 dBV. It's 10 times too low for the voltage unit scale. So what do? Well, what I would suggest is we just calibrate this to a lower voltage, and remember that this is going to be a different number than actual voltage units. So I'm going to unplug my guitar here and plug this back into the soundboard. And I'm going to select a different voltage to calibrate to, and then we'll see what that means. So I've still got my AC meter here. I'm going to turn on my sound signal. And I'm actually going to go 10 times lower. Instead of 1.228 volts, I'm going to shoot for 0.1 volts. And to do that, I will reduce my volume level. Okay, so right now I have 0.122 volts, or 122 millivolts. This is as close as we're going to get to the exact number of 122.8 millivolts. But that's okay. This is less than 1/10 of a dB different. Okay, so now at that lower level, my soundboard here is showing minus 20 dB, and that makes sense. Again, we did that calculation already. If we remember back here, we already showed that minus 20 voltage units is 0.123 volts. And so that's why we're seeing minus 20 there. Now we're of course also seeing minus 20 there, and down in the minus 20s on this guy as well. And so the question is, do we want to keep it there or not? Well, we don't. We know our guitar signal is about that strong. And let's say we want our guitar signal at 0 volts, or 0 VU. So I turn my calibration knob to 0 voltage units, and I'm going to do the same thing on the mini vump. I'm going to turn this to 0 voltage units. As close as I can get it, right there. Okay, and now I can turn my signal off, and I can turn my signal back on. And so we've got now both pedals calibrated to minus 20 voltage units, but it's showing 0. So what we have to remember is if our guitar signal shows 0, we're actually 20 decibels lower than that. And in our soundboard, we can get that lost that small signal back to the 0 voltage unit level simply by turning up the gain. Of course, if I turn up the gain here, it's going to also turn up the gain on the meters because I have it hooked up that way. And now my soundboard's being a little flaky on that knob. There's a different knob here. Okay, so now we've got 0 voltage units on, and we have a minus 20 decibel offset. So what that means again is you take the number on the screen, the 0, and you subtract 20 from it. So now this signal level is actually minus 20 voltage units. This signal shows 0, it's actually minus 20. Okay, let's turn off the sound signal and we'll plug this into the guitar directly. Again, the voltage coming out of the guitar is very low. It's only 0.1 volts. And so we've basically increased the gain in the meters without changing the gain anywhere else. So only the meter sees that boost. And so now when I strum, I can get pretty close to 0 dB. There we go, 0 dB plus 1.5 depending how hard I strum. And so both meters are showing the same types of values there. This one holds the peak value, that's why this number is always higher than that number. But now you can see that the voltages, the meter ranges are actually meaningful now. When I do a strum, I'm down at minus 3, minus 5, 0 dB, and same with my mini vump. But remember, if I get minus 3 dB on this thing, I'm actually 20 decibels lower than that. It's actually minus 23 dB going into the mixer board. So that's how you calibrate to an offset. Now you can calibrate to a minus 10 dB offset if you don't want to go all the way to 20 dB. And how do we get to minus 10 dB offset? Well, we're going to use the same equation here down at the bottom of this page, and we have 10 to the power of, we want a 10 VU offset, minus 10 over 20, and that is the same as 10 to the minus 0.5. It's a square root of 10 and then inverted, and that number turns out to be 0.388 volts RMS. This is for a 10 dB offset, minus 10 dB offset. All right, so now we're going to go back to our setup with the laptop here and turn on the signal again. And we're going to set this to 388 millivolts. Oops, I got to change the scale there. I'm just fine-tuning it using a combination of my different controls that I have available here. Okay, 0.387 volts RMS. So that is now a minus 10 voltage units. And my soundboard is showing it exactly minus 10 voltage units. And I have to plug my meter pedals back into the soundboard here. Okay, and now we'll recalibrate this knob down to 0 and change this one till it gets to 0. Alright, so now I have these calibrated to a minus 10 offset, minus 10 dB offset. We can turn this off. We can unplug this guy, stick it back in the guitar, And now when I strum, I'm going to be 10 dB lower than I was last time. So last time when I was strumming, I was getting about 0 dB or a little higher if I hit it hard enough. And now I'm getting around minus 10 dB, or if I hit it harder, I can get maybe minus 7.5 dB. And you can see the same number appearing here as well. So now I have a minus 10 dB offset from these guys. My signal level, if it reads minus 7 dB, let's say on here, the actual signal going into here is minus 17 dB for absolute voltage units. So hopefully this helped you a little bit figuring out how to calibrate and include offsets on your meters so that you can use them in normal ranges for guitar signals and keep them in the sweet spot, right where all those nice small numbers vary. We don't want to be down at the minus 20 range because everything is in increments of 10 decibels, but when you get up around 0, you've got 1 dB increments, which is a very useful number.